Good afternoon and welcome everyone to the Manufacturing Sustainability and Circular Economy webinar. For those of you who don't know me personally, I'm Caroline Cantley and I'm the Executive Director of the Scottish Research Partnership in Engineering. Today's webinar is being led by SRPe with our partners, the National Manufacturing Institute Scotland, and brings together experts from industry and academia to showcase research and innovation in relation to manufacturing sustainability and the circular economy. And we also wish to highlight some of the future opportunities and challenges ahead. The webinar is part of the Energy Innovation Emporium 2021, a webinar series from our sister pool, the Energy Technology Partnership and Research Innovation Scotland. It seeks to inform the global energy community how Scottish research and innovation can help deliver carbon emissions reductions targets, especially around the Paris Agreement's nationally determined contributions, to encourage collaborative activity between Scottish academia and wider parties. Now, to mention some housekeeping matters, the webinar is being recorded and will be available on ETP's YouTube channel. I'd ask that all attendees please keep their cameras and microphones off throughout the webinar. There's going to be a 15-minute Q&A session at the end of all of the presentations, at the very end of the webinar. So please can you type any questions you have within the chat box throughout the webinar, and at the end, during the Q&A session, I will direct the questions to the panel. If you have a question for a specific panel member, please put that in your question. Otherwise, I'll direct it to the wide open panel. So really, that's all I have to say at this point in time, and I'd like to thank you all for joining. And it's now my pleasure to introduce our first speaker. Our first speaker today is Paul Cantwell, who's the Knowledge Exchange Fellow for Energy, Oil and Gas at NMIS. And Paul acts as technical lead for the High Value Manufacturing Catapult Circular Economy Strategy Transition Group. And he also leads in resource efficient manufacturing and hydrogen economy strategic innovations programs. Within the NMIS team, Paul supports industry on their net zero journey, and he's also partly seconded to the Scottish Institute for Remanufacturing. Since joining SIR, Paul is leading on high value sector engagement, looking to identify sector specific programs, building sector roadmaps, and identifying programme opportunities for the SIR network to engage with. Paul's going to be talking about sustainable manufacturing for the 21st century. So over to you, Paul.
Thank you very much. So hopefully parties will be able to see my screen and also myself. So thank you very much for the invitation. Just a note, this work is a summary of the work that the High Value Manufacturing Catapult have been running for the past 2 or 3 years in the net zero space. I'm going to take you through 3 parts. The first part is going to be based around compelling reason for change. So as parties would be aware, it's well documented that we are overburdening the Earth's ability to support life and finite resources. There's an imbalance in the planetary boundaries caused through the manufacturing requirements and consumption and industrial systems today. And there's an unsustainable demand on consumption of finite materials, resources, requiring multiple planets or multiple worlds to deliver on the projected growth in adoption and adaptation of next generation of technologies. Some of the analysis that the High Value Manufacturing Catapult have actually undertaken is that through enabling conditions for net zero programs, we can see that the UK consumption of emissions are around about 43%, largely associated with materials processing. In all supply chain, greenhouse gas emissions occur at the interface between process, products, and the environment. That is with land, water, and air. The further downstream a manufacturer, any company that is, the greater the embodied emissions and the more difficult it is to actually understand or calculate what the scope 3 emissions are associated to our consumption of manufactured products and services. Around 80% of the environmental social impacts of products is defined during the design stage, and this creates quite a strong opportunity for the UK to try to anchor the design and anchor the innovation to try to drive change and be a leader in the market. It's also worth identifying that primary material processing is where the bulk of the manufacturing emissions occur, where we predominantly don't have an existing infrastructure, or the infrastructure has shrunk over the years or been offshored. Analysis shows that locating primary material processing in the UK can reduce the consumption and scope 3 emissions, such as steel or aluminium sectors. Evidence shows that regions that locate primary processing, anchoring downstream manufacturing, can lead the market change, can create adaptation and more sustainable practices, and create exportation opportunities. High value design locks in materials and manufacturing life cycle retention in the UK and can reduce our emissions and secure the value chain to work towards the net zero ambition against the 10-point recovery strategy and net zero legislation. It's worthwhile identifying the economic impacts and opportunities. Here's a study that's done a comparison against the climate action versus the climate inaction that parties will probably be quite familiar with. It demonstrates that economic, political and social costs of inaction is far greater than that proactive addressing sustainable needs for the manufacturing industry. We can no longer offshore where our greenhouse gas burden is associated to our manufacturing consumption of products within the UK. To help ensure critical resources are available, the UK's evidence shows that we need to shift towards the circular economy and do better with the assets that already reside within circulation of our manufacturing industry, or the assets that come into the end of their life or in circulation for planned decommissioning and recovery and redeployment. The UK manufacturing struggles to be competitive against low-wage manufacturing. However, this strikes an opportunity for us to be more competitive on green shoring, green opportunities, and working towards a net zero ambition where operators, OEMs are seeking more sustainable practices and solution and ethical sources in products and services. A shift towards the circular economy allows the UK to strengthen the resilience of its supply chain for future generations to come. It's also worthwhile understanding that there's a convergence of sustainability and digitalization that will cause a huge business model disruption, where we're going to see a potential for offshoring the supply chain to offshore our carbon footprint or our greenhouse gas emissions, or we can create it as an opportunity where we demonstrate best practice to attract inward investment and attract next generation of technologies to be built and developed as a platform of UK manufacturing and Scottish manufacturing. What we're also recognizing is that we're going to see two characterizations of companies. There's going to be the disrupted organizations who try to continue on that linear manufacturing process that's well understood and anchored within our supply chain, who don't transition or who don't understand how to transition to the net zero position. We will also have the next generation of companies and services coming through, which are the disruptors that have been created out of the climate change agenda, identifying market opportunities and growing to the demands to adopt servitization models, sustainable recovery models, and remanufacturing processes, or looking at waste streams to develop products with economical return. So how can we change? Well, by approaching the Earth as a system, we can access, measure, and regulate, controlling the variables that will allow us to identify areas of interventions and programs of interventions where we can recover value, utility, and create new value streams. Enabling a shift towards the circular economy will strengthen the supply chain base and be able to utilize existing infrastructure and assets and materials flow that are already in circulation that will conventionally be exported overseas for reprocessing and recycling. Again, a reminder that around 80% of the environmental social impact of products is defined during the design stage. So we can start to anchor the design principles within the UK to drive out some of those emissions too, and be a proactive approach. It's well documented that there are 4 key steps to achieving net zero. ensuring that carbon is being measured and monitored at all sources. There is no widely adopted cross-sectoral accounting methods at this moment in time capturing supply chain emissions. Whatever possible, eliminate the sources of emissions. So supply chain visibility is key to identify where we can reduce those emissions and offset those emissions. As we go below the tier 3, most OEMs are struggling to tackle that problem or create a clear, visible map of where those emissions currently reside or what form they actually take, so how to create proactive interventions in that area. Lack of open and quantitative data throughout the supply chain is creating issues in our net zero journey to enable us to decarbonise and practice sustainable practices within the manufacturing community. If it is not possible to eliminate it, then emissions must be reduced as best as possible and offsetting actions taken. So how is HVMC helping in this situation? How are we approaching the challenge today? We're beginning to develop a series of programs and commercial service offerings that we can provide to industry to look at the full sustainable business model and journey that a company will need to undergo to identify its opportunity in the net zero journey and to identify intervention innovation programs that they can run across their supply chain. This is a journey, this is a supply chain and sector-wide challenge where we can co-create collaborations within other industries that previously haven't been achievable before to look at these challenges. We've also in the previous years been running sector analysis, identifying the drivers, the net zero ambitions, the strategies with key industrial parties across 17 industrial sectors. We've identified over 160 opportunities that could create a better journey for industry to diversify and change that net zero position to adopt sustainable manufacturing practices. We've also identified 17 key themes that we're developing and we'll be announcing in the coming year to drive intervention innovation programs that will be complementary to various sectors such as aerospace, automotive, food and drink, waste and such areas. To give you an example of some of the analysis we've been conducting within the high value manufacturing sectors, here's an example of the development and technology needs for aerospace, where we've identified some of the obvious areas such as alternative propulsion fuels, but we're beginning to look at the fundamental design principles and whole systems thinking around how can we design future aircrafts so we can recover the material, make appropriate selection and recover value and utility to use those as assets and feedstock for either next generation of aircrafts or alternative industries that are in demand of those materials at more ethical and economical value balanced. For our analysis and through the 160 opportunities we've identified, we've actually highlighted 9 cross-cutting themes, thematic areas that we're actually beginning to develop and work with industry to understand what potential intervention innovation programs can be. Looking at some of these from external environmental drivers and factors to redesign of business models to requirements around new skills, methods and tools to enable the manufacturing community to progress to the net zero ambition. A good example, one of these programs is such as through life engineering and product in use. How can we advance the process of asset management? How can we encourage local content to be created to deliver on the 10-point recovery plan, such as the local content for floating offshore wind capacity for manufacturing? And how can we drive better informed decision making of mapping what the actual environmental impact of those assets are, both during operation, during the manufacturing phase at end of life, and how can we offset that associated greenhouse gas emission or embedded carbon footprint to return value and return market export opportunities in both products and services for the future. A good example of one of the programs we have developed is the Sustainable Composites, the SUSWIND program, where it's a joint industrial program with industry and the catapults to try to look at one of the very burdening waste streams that are coming from the decommissioning of wind turbines and looking for alternative uses or reintroduction of material back into the supply chain to create local content to deal with our waste streams locally and try to offset the negative press that will come around from mismanagement of assets at end of life. In summary, climate change is an urgent driver and needs to be a prime objective of industry. Strengthening the whole systems thinking around design and life analysis and capabilities is key to unlock the true potential for our future generations of products and services to become more sustainable. It's needed to develop pilots to provide examples of implementation to demonstrate the decarbonisation of those supporting services and to demonstrate to the global environment how we can operate on a more sustainable practice and bed in. Implementation to drive forward in interventions for disruptive opportunities, to establish a carbon accounting framework to standardise that approach, so it's standard across industry sectors, so we can create a true position of what is actually required, where are the interventions required, and how can we start to implement things such as urban mining or better recyclability of materials to reintroduce into market supply, to establish a digital system for effective emissions accounting and tracking and reintroduction of materials into the supply chain. All I have to say is thank you very much. We'll take questions at the end, and if you want to get in touch, please drop me an email. Thank you very much.
Okay, thank you very much, Paul. That was very interesting as ever. I've heard you speak before, and there's lots of good material in there to provoke some more thoughts from everyone who's in attendance today. I think you really stressed the criticality of taking a whole systems approach to the challenges and in order to take advantage of the opportunities ahead. It's now my pleasure to introduce our next speaker, who is Professor John Ahmet Ergayungal, who is head of the Centre for Digital Engineering and Manufacturing at the School of Aerospace, Transport and Manufacturing at Cranfield University. John is a professor in digital engineering and is head of the Centre for Digital Engineering and Manufacturing. His research interests include digital twins, augmented reality and digitalisation of through-life engineering. John's title of his talk is An Overview of Through-Life Engineering Services in a Digitalised World. So over to you, John. Thank you.
Thank you, Caroline. So hello, everyone. Today I'm very happy to be making this presentation. I prepared this presentation on behalf of the Through Life Engineering Services Council, which I'll be introducing in a moment. So what I'd like to cover in this presentation is firstly to give you an overview of what is Through Life Engineering Services and give you an idea about where it's being applied, how it's being applied, and what are the kind of new themes that we're experiencing around the digital engineering. So just to begin, with Through Life Engineering, we're talking about long life assets, assets that are typically 10 to 100 years in life cycle. They're complex engineered products, they're systems, they're complex system of system type architectures. The other thing to really bear in mind here is that they have a significant in-use support investment that they need. So when we kind of provide a definition of TES, it's a combination really about capabilities, techniques, business thinking, and network behaviors. And we're really trying to understand how major assets can be optimized in terms of the value and cost. So here we're really, as an example, just looking at things like how do we keep the asset working longer? How do we actually make it more economical to use this? Just to go into more detail, in terms of value, and the term value is really important in the Through Life Engineering Services type context. So we define value in terms of the kind of product related aspects. So it could be things like functionality, performance, availability of the asset. It could also be things related to cost. So how do we look at expenditure? How do we actually operate, maintain, repair, and get better value in terms of the money that we invest in it? So we're really trying to understand value propositions. We're trying to optimize the value over time. And it becomes more and more complex when we consider the long life cycles that we're interested in. So in terms of the TES Council, and this is co-chaired between Steve Gregson at Rolls-Royce and myself. And what we're really trying to do here is create the ecosystem. So we want to be able to guide the UK in terms of skills, technologies, the supply chain, the kind of regulatory environment and the commercial framework, so that we are competitive globally and we can develop the right means to deliver these long life cycle type solutions. So this is where we're trying to look at the life cycle in a holistic manner. So if I look at the bottom left figure in the slide, so we're trying to look at the different phases in the life cycle. How can we bring these together so that we have a much more integrated perspective to these complex systems? So just as an example, this is probably one of the most commonly provided examples whereby Rolls-Royce provides power by the hour as a solution. And this is where we're moving away from traditional ways where companies sell maybe spare parts and don't necessarily understand the end outcomes in terms of the customer's expectations. With the shift towards TES, there's a lot more understanding of the outcomes in terms of the benefits that you get from the asset. So here, the asset availability becomes much more important, and this is creating new business models. So instead of being paid based on the parts that you're selling, you're being paid based on the availability of the asset or other types of outcome-based solutions. So this is really how TES, Through Life Engineering Services, is being applied in this example. Now, I'd like to just highlight a recent document. It was published in 2018, PAS 280. So it's really trying to explain how Through Life Engineering Services can actually add business value. We developed the framework, and the framework is kind of summarized in this figure on the slide. It's really trying to bring together the different activities that you conduct to generate a business outcome. So here we're trying to bring different phases of the life cycle, such as develop, prepare, utilize, retire, and connect these in terms of the different value streams, how we can generate value across the life cycle, and map these against the business context. And with this, we're talking about different business models, we're talking about different kinds of organizational maturity, and we're changing the mindset from just deciding engineering-related kind of decisions to a much more integrated perspective where we've got the business and the engineering outcomes brought together, and we're trying to derive value, and that's the key thing. So I guess with TES, this is really the novelty. It's not necessarily just about delivering repairs, maintenance, or an engineering solution. It's about having a business conscious perspective on how you deliver these engineering related services. The other thing to highlight here is that you also need to consider the enabling capabilities. And this is really about what kind of technologies, what kind of solutions can you actually develop so that you're meeting these value driving solutions. So in this presentation, I'd just like to go into a bit more detail on the digital solutions that are emerging and how they're actually contributing to generate value. So along these lines, there are four main themes that we consider value generating. So firstly, around avoid. So this is where you're doing things so that maybe you're avoiding the degradation of the major assets, so that you're controlling, you're really reducing the potential impact. The second area is around contain. And this is whereby you're checking how the asset's being operated, you're collecting information, you're trying to be proactive so that you're sustaining the use over time. And the third area is around recover. So recover is looking at the case where maybe the asset's broken down, and now you're bringing it back to a state where it can actually function at the level that's acceptable. And then the fourth area is around convert. So this is where it's looking at the experience to generate incremental value. So we're learning from the experience, we're trying to improve on our understanding over time. And the interesting thing here is that we're looking at applying these things across the life cycle, different phases of the life. And we also need to think about the differences between the assets and the support assets that you're using. So we really need to think about the interchange between these different assets and the support assets, so that we're developing a through-life solution that's integrated. So with that, I'd just like to give some examples in terms of the avoid context. So just to go into a bit more detail here, avoid is focusing on things like, how do I minimize the cost of the through-life solution? How do I maximize the effectiveness of the different interventions that I may plan over the life cycle? And how do I minimize the number of interventions that I may need to do over time? So in this context, we've been working on digital twins. And you can see here in a gearbox example, we're trying to connect the digital twin to augmented reality. So what you can see here is that we are in real time representing the gearbox example, and we can actually overlay information such as CAD drawings or user manuals to assist in the process of conducting different tasks. So here, it's really a tool to avoid maybe future interventions, minimize the types of interventions that may be needed so that we're planning much more effectively in terms of how we want to deliver the different interventions over time. Just to move on to another example. So in the context of contain, so this is where we're trying to mitigate operational risks. We're tracking the life of the asset. We're trying to understand the health, and we're resolving specific risk issues as and when they may arise. So in this context, we've again looked at digital twins, and what you can see in this example is we're representing a health system. So we've got a client mission computer, we've got various like camera systems, and this is where we've got the digital twin that's showing in real time whether what the state of the system is. So here you can see we've got 100% CPU, 20% RAM, temperature, and we're now just going to remove a cable, and the digital twin is going to realize the change that's taken place in the client mission computer, and the digital twin is going to capture that change. So you can see it's become disconnected, and that's kind of where we're trying to go. And this is just a very, very simple example. And in the future, obviously, we're trying to understand this complex system of system kind of interfaces. Just to continue, in terms of recover, we've been looking at, so in the value adding activity for recover is really about how can we bring the asset to an acceptable condition where it can be used. It could be about how we improve the inspection times. It could be about how we improve the repair times or replaceability and disposability. So here we've been looking at augmented reality in terms of providing step-by-step guidance, whether it's for the inspection, whether it's for actually conducting the maintenance or repair activities. So the kind of dimension we've been looking at is how do we provide adaptive guidance? So rather than having fixed guidance for particular tasks, we're trying to understand the skills of individuals. We're trying to understand what would make different tasks easier, better for different individuals. And in this process, we're also looking at how do we capture tacit knowledge so that we're learning from people and we're actually trying to improve future operations. So this is a kind of direction that we're going, which is already showing some signs as to improving the time it takes to recover different conditions. In terms of convert, I think there's numerous things that can be done, but here we're really trying to understand the connection between the knowledge of people and the experiences that we're generating from different value generating activities. So we're trying to identify these, we're trying to prioritize them, and we're trying to justify the different risk management and opportunities for improvement along these lines. So we've also, as Test Council, been looking at how do we prioritize different technologies that are being built. So this is one of the key aspects that we're trying to really drill into a bit more, because we've heard from many people, many companies, whereby there's lots of opportunities like AI, like digital twins, like augmented reality, but how do we choose which one, and how do we justify which technology to invest in? So as Test Council, we've developed a step-by-step process where we're looking at capturing what is the problem, we're looking at understanding the different technological options, and then we're trying to provide a step-by-step process to prioritize among these options. And finally, we end up with a return on investment type analysis, whereby you can justify and options. So just to conclude, I'm conscious of across customers and wider stakeholders is much more prevalent, and we need to think about value. We need to understand how the value across the life cycle evolves and changes as it's very much dynamic. And we also need to understand how there's a growing emphasis on digital technologies. So making use of data, making use of models, and understanding the connection between business commercial gains and also engineering activities is critical. So moving forward, I think technology is driving faster and faster changes, and we need to think about how we can embed these changes so that life cycle solutions are always going to be improving and enhancing the value that they offer. So with that, I'd like to thank you all and look forward to answering questions later on. Thank you.
Okay. Thank you very much, John. That was very interesting indeed. And when you first spoke, it even came as a surprise to me that we're looking at, timescales of up to 100 years for some of these things. And also you highlighted again the need for an integrated kind of holistic approach to the whole TES arena. So thank you for that. Our next speaker I've got the pleasure of introducing is Dr. Ian Mitchell, who's the Chief of Technology Repair and Services at Rolls-Royce. Ian's been with Rolls-Royce since 2009, and he's worked in various technical and leadership roles in technology development, materials science, and project management. In his current role, Ian is responsible for the global repair and services technology portfolio, delivering innovative technologies to support Rolls-Royce products in service. This is a diverse portfolio ranging across multiple projects, utilising advanced miniature robotics to keep engines on wing, to developing the next generation of component repair and inspection technologies for use in MRO facilities. Ian's talk title is Sustainability Through Services, or slightly tweaked now to Sustainable Servicing. So over to you, Ian. Thank you very much.
Hi there. So thank you, everybody. Thanks for the opportunity to talk a little bit. And I guess nice introduction from John as well to some of the comments that I'll be talking in a minute. So I guess from my perspective, the pitch that I want to present to you today is talk a little bit about Rolls-Royce and our journey towards net zero, and touching a little bit on our product strategy in that regard, but then focusing on our sustainability and servicing business model, which was really well teed up by John and some of the PAS 280 thinking that we're starting to embed within our organisation. So if we go on to the next slide, please. So I guess just to start, Rolls-Royce, we continue to invest and undertake research across various opportunities that are integral to our future programmes and decarbonisation strategy. So we're looking to reduce fuel consumption, emissions and noise on our products in line with various commitments we've made. And this is underpinned by the technology development across our low carbon technologies and the underpinning enabling capabilities, some of which I'll touch on later. And we've made a commitment from an operations perspective to move towards zero greenhouse gas emissions from our facilities by 2030. So next slide, please. So I'll touch very briefly on the product strategy, although most of the presentation is really trying to talk about servicing. But to give you a feel for where we're heading, and some of this is probably quite well known in the news, but three key areas for us. The first one is continue to improve gas turbine efficiency. The second is to collaborate on sustainable aviation fuels, big opportunity for us in the aerospace market. And looking more radically at alternatives such as electrification, hybridization, and embracing hydrogen as a fuel going forward. These three key areas are underpinned by enhanced integration at platform level, so further improvements in efficiency to be generated through more embedded architectures, working more closely with the airframe to see some of those improvements. And a lot of this is underpinned by continued investment in world-leading manufacturing, digital and services technology. If I touch on the gas turbine side of things, gas turbines will be fundamental for many years for large aircraft and also for hybridization steps going forward. A large ultrafan engine, as an example, which is our next major development from a product perspective, will be 25% more efficient than a Trent 700, which is our most large number installed fleet currently, and 10% more efficient than our Trent XWB, which is our best-selling new engine. We've already started looking at sustainable aviation fuels, and our newer products are compatible with those fuels and various fuel mixes going forward. And then as we look at electrification, we're starting to look, our strategy is built very much on fully electric for smaller aircraft, where we're looking at, say, air taxis or small numbers of people flying on light aircraft. As we move into medium-sized planes, we're looking at hybridization. And then for the larger aircrafts, we're looking at continued efficiency improvements in gas turbines, moving to SAFs, and then ultimately, can we run those on hydrogen fuel? So that's a product perspective, but I guess the key thing that I wanted to talk about really is our services strategy and some of the business and sustainability elements of that. So if we can move on to the next slide, please. So John in the previous talk did a good introduction to some of the models that we utilize within the business, and I guess probably the most best known from a civil aerospace standpoint is our use of long-term service agreements, which effectively retain product stewardship for Rolls-Royce. So Total Care is probably one of the best known examples of that, and that's effectively where a customer is charged a fixed dollar per flying hour, and therefore we are rewarded for the engine to perform, and it rewards reliability, a factor which is obviously highly valued by our airline customers. Total Care option removes the burden of engine maintenance from the customer and transfers the management of the associated risks to Rolls-Royce. We actively manage the entire we actively manage the engine through its life cycle to achieve maximum flying availability. And Rolls-Royce and our customers are both rewarded by keeping engines on wing and in service. And this aligns our business model with airlines, keeping the goal of keeping engines flying. There's also a good connection with sustainability, and I'll touch on that in a second. The challenge really that sits across all of this is the challenge presented by such a complex product in an arduous operating environment. And the image on the right-hand side is something we've shared previously, but gives you a feel for the kind of complexity of managing these products and service. A typical Trent engine travels equivalent to 20 times to the moon and back between overhauls. So the challenge in maintaining reliability there and providing all the systems needed to support that is not insignificant. So we can go on to the next slide, please. So this is where I wanted to talk about some of the service value levers from a value perspective, but also the environmental levers. And I guess it's a very simplistic chart, this, but it's picking up on some of the points that we've made previously. So I'm picking up on the avoid, contain, recover, convert language, and just putting on the slide here our interpretation of those key value levers from a business perspective. So really we're driven, and our customers require us to be driven by the need to perform maintenance through better design and operation. So this is maximising the time between service intervals, this is getting the design right, and this is avoiding the need to intervene when we're not planning to do so. When we do need to intervene, we need to contain the impact of this intervention, and we need to contain the demand for maintenance such that we can avoid disruption to our customers' operations. Once we do get to a maintenance or a scheduled shop visit, we're all about recovering the asset and recovering the life and performance through cost-effective maintenance. And that's the thing that sits at the heart of that, is about converting all the experience as we go through that cycle, whether that's inspection of components, understanding component condition degradation, and feeding that back in to gain incremental improvement in our operations and our service potential. When you overlay the environmental levers of reduce, reuse, and recycle on top of those service value levers, you can see some really interesting synergies between the two. And I guess what I'm hoping to do today is try and give a relatively practical example of where we're applying some of this principle from a sustainability perspective in an environment which is clearly a challenging one from a journey to carbon neutral. So when we talk about reduce, this is really all about keeping engines flying for longer. So there's less demand on new products and components. Clearly we use highly alloyed materials that require a lot of energy consumption to manufacture in the first place. And we can maximise the service life of those components by minimising unnecessary component replacement. If we can also avoid engine transportation, the need to fly mechanics out to perform maintenance, all of that is beneficial from a perspective of running a sustainable business and reducing energy consumption. Once we need to perform activity, we look at reuse, and we're increasingly looking at our ability to repair individual components. And we're now able to repair more than we ever could before, and are actually starting to look at how we can perform this rectification work and repair when the engine is in its fully assembled form, close to the wing. So again, trying to move that maintenance from the high energy consumption of removing the engine, shipping it around, inducting it into a shop. Can we do as much of that on wing as possible, minimising customer disruption, and also supporting our business model. When we finally do get to scrapping components, we're looking at recycling. So this is taking the raw material and reverting it back to use in the product again. And about 50% of the raw material that we revert makes the grade for use in aerospace again. The material that doesn't meet that grade can be sent to other supporting industries where the requirement for quality is not quite so stringent as it is in the aerospace environment. So it finds its way into places like automotive, and even into golf clubs when we talk about things like titanium alloys, etc. Okay, so that's a little bit about service value levers that we used before, and also the environmental connection between those. And then the last couple of slides that I just wanted to touch on very briefly, and some of the practical examples of where we're using this thinking in our technology portfolio. So digital systems are really important to us, and this is about reducing the need for intervention. We gather a huge amount of data on engines during performance, where they fly, how they're operated. Combining this with advanced analytics enables us to be proactive in planning our maintenance and repair activity, and therefore minimising our disruption. And when we take those digital technology developments and augment them with the insight that we can gather from things like inspection capability and advanced engine health monitoring and management systems, we can then connect that with knowledge of component flight path conditions, the air it's flying through, etc. And we can result in a more intelligent support to our customers and treat each engine on an individual basis. The thing that underpins a lot of our digital activity is inspection technology, and this cuts across a number of different fields, from the more direct interaction of advanced non-destructive evaluation, which allows us to do high sensitivity crack detection to maximise component life and reuse as much material as possible. But we're also looking at things like machine vision technology, which can aid inspection both at an engine level and at a component level, really providing insight in terms of component condition, degradation, and driving our understanding and improving our life in calculations right at the beginning. So we look at condition monitoring. We're also able to close the loop with repair by understanding scrap drivers and allowing us to forecast our requirement for repair capabilities and develop those technologies ahead of the requirement in service, and also react as our customers invariably change the way they operate our products. And 3D scanning is another technology that is very useful for us, both from a component inspection perspective, but also to be used as a backbone of an additive process. Really important in the aftermarket, where every component that we see is different to the previous. Variations in distortion, variations in component condition. And when you connect that knowledge back in with the information we gather from manufacturing, you can start to build up that digital twin of the components through life experience. And the final piece on this slide is service intelligence. And this is really where the convert stuff lands in terms of the hands of the engineers. So this is all about placing data quickly and securely in the hands of engineers and people that can consume the information. So this can be simple things like advanced search tools, which speed up the ability to acquire information, connecting our fairly distributed MRO supply chain and repair facilities to provide data on component degradation, on how engines are operated, etc., and providing that back to engineers so we can optimize both the design but also the service instructions and speed up the ability to change and react to those. This all reduces waste and optimizes our product's operation. So if you can move on to the final slide, please. So here's some of the more, I guess, hard engineering, more traditional manufacturing type capability that we've been looking at within the context of the service business model. So I mentioned before about the reuse. So this is all driven by advanced repair technologies. Obvious examples of this are additive manufacturing. And apart from the clear benefit from a net shape perspective of minimising the amount of material used to perform the repair, we also have highly complex and expensive components where we see small amounts of damage. A bliss component is a great example where you've got 200 blades attached to a disc. You may see small damage on one of those aerofoils. By going in and additively repairing just that area, you can obviously retain that component and put that component back out in service to ensure that it uses up all of its useful life. Additive technologies give us the benefit of being able to repair complex, highly alloyed materials, minimize distortion through low heat input. And as I mentioned before, the backbone of those types of processes is having available 3D scanning and inspection technologies, which allow us to adapt the process both for part-to-part variation as the input condition, but then also account for variation as we start to repair those parts and we start to apply heat and various different processing steps, whether it be the additive, the heat treatment, or peening or polishing, and the part starts to change through that cycle. We can correct that, produce a conforming part and maximise the amount of material reuse. Another area within the context of that is looking at things like how do we deal with part-to-part variation through manual welding capability. So we do a lot of manual welding within the aerospace environment, but as we drive our products and performance harder and harder, the components become more difficult to repair, thinner sections, easier levels of distortion, more complex components that are difficult to access for a manual welding capability. So looking at semi-automating that capability to allow us to restore component geometry, but also fit, form and function on these large and complex components that enable some of our future architectures is a key area of interest for us. In the centre box, we've got in situ repair and inspection. This is really quite an exciting area for my team and for us within Rolls-Royce. I tend to call this keyhole surgery for engines. This is where we're looking to deploy as much capability as we can through a borescope port. This is really driving at that ability to avoid having to drop the engine from the wing and break it down to piece part level, which is not only energy intensive, but clearly costly from an operational perspective and also a financial burden. So we're looking at things like snake robotic devices that are only 10, 12 millimeters in outer diameter that can perform, can reach deep into the engine, 4 millimeter working channels down the center, so we can deploy different capabilities down there, whether it be material removal through things like air-driven grinding tools, and provide lasers down there for material removal, but also analysis techniques, and also deliver inspection capability and NDE capability right into the heart of the engine. And then ultimately, as we look forward, can we deploy things like additive technologies and coating technologies to restore component performance in a built-up state? And also related to that, we're looking at things like wireless cameras, so we can place cameras deeper into the engine and perform rapid inspection of a number of stationary components by turning the engine and capturing that data. And all of that information from an inspection standpoint then feeds back to the machine vision technology that we talked about at the beginning, which allows us to interrogate that quickly. And the final piece, just to finish on, I guess, is the enabling element. So clearly, as we look to these future architectures, it's really important that we're developing the capability and ability to be able to service these products in the future. So meeting the challenges of things like the new material types, whether it be composites, as in the picture there. How do we repair? How do we remove material? How do we inspect composite systems, very complex systems, very different to our traditional metallic systems. And then as we move into some of the other areas like electrification, etc., meeting the challenges of those particular environments, whether that be an inspection or repair requirement, dealing with things like hybridization. How do we demagnetize rotors so we can disassemble and operate within magnetized environments to allow us to perform rectification work and to service those products. So that's pretty much the end of our presentation. So thank you very much for time. Hopefully we gave there a relatively practical example to link back to some of the stuff that John was doing, for example. And clearly I'd be happy to take any questions at the end of the session. Thank you very much.
Right, thank you very much, Ian. That was extremely interesting, and you really highlighted the strong alignment between the service and environmental levers, and also the role that digital technology and research and innovation will continue to play into the future. I'd also at this stage like to remind people who may have joined a little after the start that we're going to have a Q&A session for all of the speakers at the end of the webinar. It'll be a minimum of 15 minutes, and the only way for you to submit questions really is through the chat box. So I'd really encourage everyone who's joined us today to submit some questions now. It's not too early. It will give us time to prepare and select questions. We'd appreciate that. So anyway, thank you very much again, Ian. I'll now move to our next speaker, who is Professor Chris Dungy, who's the Research Director at NMIS, the National Manufacturing Institute, Scotland. And in terms of Chris's background, as the Research Director, Chris blends academic and achievement with significant strategic and operational experience from across world-leading industrial, academic and research and technology organisations. Chris previously worked at TWI and Lancaster University, where he was the Director of Joining 4.0 Innovation Centre, J4IZ, and has also worked across team and technology leadership roles within Rolls-Royce, the Manufacturing Technology Centre and GKN. Chris is going to be talking today about manufacturing sustainability in the circular economy in the context of NMIS. So over to you, Chris. Thanks.
Well, good afternoon, everyone, and thank you for that introduction, Caroline. Greatly appreciated. Just checking, can you hear me okay, Caroline?
Yep, all good.
Brilliant, okay. So without further ado, if you'd like to go to the next slide, that'd be greatly appreciated, Sarah. So in terms of what I'd like to cover off today is really to give you a very good overview of the National Manufacturing Institute of Scotland, particularly focusing on our strategic innovation direction, which is now pivoting very much towards the net zero carbon emission agenda. And also what I'd like to give very briefly, time permitting of course, is an overview of recent and diverse case studies that we have focused on the sustainable manufacturing agenda. So we're looking at particularly the remake agenda, looking at tool die repairs, repurposing of face masks, next generation blade manufacturing for offshore wind, and also whiskey cask filling as well, in terms of the efficiencies that we've helped develop and embed within the kind of industrial organisations. So in terms of coming back to the top, as it were, in terms of the institute itself, it's the National Manufacturing Institute of Scotland is a group of industry-led manufacturing R&D facilities where it very much brings together research, industry and the public sector. So working together to transform skills, productivity and innovation. And this is very much to make Scotland a kind of a global leader in advanced manufacturing and to attract investment into the nation as well. Next slide, please. There's a couple of reveals on this, so if you just go through those, that'd be greatly appreciated as I talk. So in terms of the research and innovation ecosystem within NMIS and the wider network it interacts with, we apply this TRL model, so technology readiness levels. So looking at 1, early innovation, research kind of blue skies thinking area on the left-hand side, all the way through to level 9, which is the technology implementation through to commercialization. So we very much sit in terms of the kind of mid-TRL landscapes, the applied research and development environment. And we very much work part of a wider network across the United Kingdom called the High Value Manufacturing Catapult Network. So NMIS is the only entity within Scotland, so you can see on the graphic centre bottom there. It's very important to point out we work very closely with SRPe and the world leading universities in Scotland, of course, and as highlighted on the graphic on the left. And we've got a network that's now developed and running, particularly in the advanced manufacturing context, as you'd imagine, also robotics and autonomous systems as well. On the right-hand side, we try and work very closely with industry as well. So we've got many members as part of NMIS or the AFRC, which is the Advanced Forming and Research Centre, which is part of the NMIS group now. We're looking to expand that very rapidly with new members as we go forward. But particularly what I'm focused on in the moderately early days of the National Manufacturing Institute of Scotland is looking at a number of technology solution providers, from a pure manufacturing capability through to the digital technology solution providers that help us develop innovative world-leading technologies and capabilities, which very much complement the previous speakers' comments on the use of digital capabilities to enable kind of the through life engineering services vision, as it were. Next slide, please. I just have to quickly highlight that we're part of the One Scotland team, so very much supported by those key stakeholders on the slide here, particularly the Scottish Government and the High Value Manufacturing Catapult Network, but there are many other key institutions and entities that are very much at the heart of NMIS. So we work very closely in a kind of Scottish and UK context as well. Next slide. Briefly, in terms of the group of NMIS, so we've got a combination of core capability, specialist technology centres and an active network of partners in the manufacturing community in Scotland and beyond. What's highlighted in yellow are the specialist centres that are already up and running and been delivering world-leading innovation and impact for many years, particularly the Advanced Forming Research Centre and also the Lightweight Manufacturing Centre, which I'll highlight in a short while with one of the particular case studies I mentioned earlier. But we've also got about to come online the digital factory opposite the airport in Glasgow, which is a very exciting entity and part of the NMIS journey. But within that, we've also got a collaboration hub and manufacturing skills academy as part of the bigger NMIS headquarter facility that's going up. And my colleague Stuart McKinley, who comes after me, will no doubt give you a very good overview of that, what's going on in the manufacturing skills academy. Next slide, please. So in terms of our strategic innovation priorities, and this is where we're very much developing capability with our partners across Scotland and the UK, and also aligning our substantial grant awards from the High Valley Manufacturing Catapult Network and the Scottish Government as well. We're very much focusing on the net zero agenda, so there's several entities and pieces to that as shown on the right-hand side of the slide. But particularly what we'd like to identify is that we're developing the manufacturing context within these entities, because it's very difficult sometimes to nail it down in terms of identifying what is the real manufacturing opportunity within these emerging sectors, and that's something that we're very much working on in partnership with the stakeholders across Scotland and beyond. To give an example, on the net zero of hydrogen, we're very much looking to help support the development of an end-to-end hydrogen supply chain across Scotland and the UK. We're also looking at other aspects, particularly around design and manufacturing. So again, picking up a few notes that were mentioned earlier about the design aspect is fundamental to enabling, a sustainable manufacturing future, as it were. The design all the way through to the use of the product has to be fully considered at the beginning, and all those kind of attributes developed at the time of conception, as it were, of the new products that you're developing. So particularly with the hydrogen, we're looking at electrolyzers, hydrogen storage systems, heat exchangers, and also looking at how we can help support the hydrogen propulsion for the aero and the automotive markets as well. Net zero resource efficient manufacturing, we've particularly got a focus around what we call the R's, remanufacturing, remaking, recycling, particularly looking at life cycle analysis and modeling through like emissions and materials and usage. I think that's probably one thing to pick up, Caroline, as we have a bit of debate potentially at the end, is about this standardization and methods of accounting for carbon emissions during manufacturing, and how we can actually come to the realization, the exact amounts of carbon we are emitting. So that's your baseline, and you can work from there in terms of how to minimize that, which is another element of what we're focused on, is looking at material net energy reduction from manufacturing processes. Many of these areas are cross-cutting, of course, and as mentioned earlier, you can't really do one without the other. So having digital transformation and digital capabilities embedded with your development of your products and your manufacturing processes goes hand in hand. Also looking at lightweighting for mobility agenda within NMIS, particularly looking at how we can develop hybrid material systems and deploy those effectively to enable kind of a significant reduction in emissions for new mobility challenges. And also underpinning this is developing resilient supply chains across the UK and Scotland, in particularly, especially in some of these areas which are in the very early days of development. So hopefully that gives you a very good feel of the kind of overarching direction of travel and our innovation focus within the Institute. Next slide, please. So in terms of some specific case studies, I'd just like to highlight several that we're working on that are very relevant to this particular context today. So this first one is particularly focused around, it's called Digital. It's looking at the remake or remanufacturing agenda and deploying digital tools to enable this in the most cost-effective manner possible. And that's one of the key challenges as well, that whatever you develop in this space, you have to clearly make it cost-effective as well to really gain traction with industry. So we're really here looking at developing new methods which reduce cost, improve life and functional performance, particularly of tool dies in this instance, but this can be extrapolated out to components as Ian mentioned earlier and showed on one of his slides a repair of certain components in an engine. You know, this technology is being deployed at that level as well. So if you go to the next slide, hopefully this will be some nice video playing. If you click through again, hopefully the second video will play, but it does, brilliant. Okay, so the real key to this program was looking at this digital die remanufacturing. So as shown on the graphic in the bottom left, it's very much looking at bringing a variety of kind of capabilities together in one here. So effectively what you're seeing in the video is the damaged component being repaired using laser metal deposition. So you've got a coaxial nozzle, laser being deployed through it, and you've got powder being blown very discreetly into the area of damage in the die region in this particular instance. And as Ian mentioned earlier on, of course, it's about that efficiency of repair as well, and the efficiency of material that you're depositing, and obviously ultimately enabling this component now to go back into service, whereas previously it would be discarded, which is a great shame. So in this particular instance, we developed a digital framework based on additive manufacturing here on how to accurately and very rapidly bring together a number of capabilities, from scanning the component to understand where the damage was, and then sanctioning a specific repair strategy using the laser deposition method, coming in adaptive machining to remove the area that's been deposited, and then ultimately returning this to in service to carry on as part of the production process. So the framework was developed, and a series of, as you can see from the video footage playing, examples that have been showcased as part of this kind of overarching capability. Next slide, please. Kind of going to the other end of the spectrum almost, from that was metallics very much now to more of a kind of the polymerics side of things. So in working in collaboration with SIR, we're looking at a project here, repurposing of household face masks. It's relatively early days, but we're hoping to continue this project from where we've currently got to, but it essentially aims to investigate ways to repurpose used household face masks into feedstock material for 3D printing. This is very much based on the fused filament fabrication process. It's essentially, and it's very pertinent, of course, and consider the amount of face masks that unfortunately have been discarded, and what do we do with the waste, which is now substantial. So the process here that we've developed is looking at how to separate the face masks effectively. As you can see, that there's a number of components to this. Then shredding them as part of step 2. Then shredded fabric pieces were melted, densified and solidified into polymeric sheets. Sheets were granulated and then obviously fed into an extrusion machine and extruded the filament wire, as you can see on the bottom right hand side of the graphic here. So just give an example, very early days on this particular project, but again, we'd like to work with people on the line here potentially on how to move this forward and scale this up as well, because you can appreciate the volume and therefore the challenge that faces the UK and also globally, of course, within this context. Next slide, please. In terms of our kind of energy generation innovation priority area, we've very much been looking at developing new wind turbine blade sets to make green energy even greener. So our lightweight manufacturing centre, as I mentioned earlier, is a part of the institute itself, is working with a consortium on an Innovate UK funded project, and this is to develop an ultra-light and sustainable wind turbine blade. And this will produce nearly 10% more energy than conventional blades. Very privileged to be working in partnership with ACT Blade over in Edinburgh, University of Sheffield's AMRC, and of course OREC as well, the Offshore Renewable Energy Catapult. So the new technology that's been developed here replaces the heavier glass fibre traditional design that's been used for wind turbines, and this has a lighter, the technology developed is lighter composite structure. It's developed a lighter composite structure wrapped in a sail-like textile. So the opportunity here really is we've developed a lighter blade that now allows for longer length components. This is 10% been generated, and now generates over 9% more energy for the same wind turbine, helping to make offshore wind which is currently one of the most expensive energy technologies, easier and cheaper to harness. So just briefly, it was a £2 million Innovate programme. We've created 4 13-metre blade sets. Blades are based on the original designs of Vestas V27. There's been a series of proof and fatigue tests undertaken at OREC. Field tests have been undertaken at Myers Hills. 3 catapults have been involved. including NMIS, of course. LMC, which is the Lightweight Manufacturing Centre, supported the design for manufacture, manufacturing and assembly. So the next slide will actually show you some of the products that have been produced, and you can just get a feel for the scale of what's been developed here as part of this excellent program. And of course, on the left-hand side, showing you the test facility at Blythe at REC. Next slide, please. So the manufacturing and assembly aspects, cross-catapult collaboration was centered at the LMC to support the blade. This has included design for manufacture, FEA analysis, finite element analysis, manufacturing trials, lamination, infusion and assembly support. So ACT Blade in this instance benefited from Innovate UK funding to accelerate the programme and gain valuable research and commercial information, and this essentially underpins their business going forward in terms of the new product that's been developed here. Next slide. And just very briefly, I think I've almost come to the end of my session here. Even in whiskey cask filling, we can apply the sustainability angle here. It was actually a challenge around accurate and repeatable fill levels for whiskey production. As you can imagine, there's hundreds of thousands of whiskey barrels filled every year, several hundred litres per barrel, depending on the size of the barrel. No two barrels are the same. They vary substantially. The current method is manual, effectively like filling your tanker at a petrol station. So what we developed here was a physical system, but very much enabled with digital capabilities to model this via a digital twin in advance, apply CFD to enable it to understand advanced methods of fluid flow. And what this really did enable was accurate, repeatable filling to over 99% accuracy every time each individual whiskey cask came about and to be filled. So not only did it minimize under fillage, it minimized spillages as well, which are quite expensive for the industry because they still have to pay, unfortunately, still have to pay tax on this if they spill it as well. So on a number of levels, the resource efficiency was very much at the heart of this challenge here, and clearly underpins a more sustainable way forward for this industry. I'll just drop onto the last slide now. So I won't read this verbatim, Caroline, I'll hand over to you very shortly, but the future of sustainable manufacturing innovation in Scotland is very much, we'd like to believe that's at the heart, NMIS is at the heart of that, working very much as part of a network of capability partners across Scotland and the United Kingdom. And what we're doing here is hopefully showcasing capabilities and new technologies that will enable businesses to pivot into the kind of these new environments, particularly focused around the net zero agenda, as I highlighted earlier, as part of the strategic innovation priorities. So without further ado, Caroline, I'd like to thank you all again for allowing me the time to present today, and I'll hand back to yourself.
Thanks very much, Chris. As usual, a great presentation, some really interesting case studies in there, particularly the piece about the recycling of face masks. I'm very interested to find out more about that. Thanks for that. And we'll now move over to our next speaker. There's been a slight change to the order here. Our next speaker is Paul Sheeran, who's Chief Executive of Scottish Engineering. Paul joined Scottish Engineering in 2018, having previously held the role of Managing Director for B&W Diamond Power Speciality Limited. Paul is originally from Thurso in the north of Scotland, and he studied electrical and electronic engineering at the University of Glasgow, and he joined Nuclear Electric in 1990 as part of the Sizewell B project team. After a period of working in the US, Paul returned to Scotland and joined Polaroid at its Dumbarton base in 1996, and again became Managing Director until 2017. Paul has been a keen volunteer and supporter of Young Enterprise Scotland, acting as Skills Business Advisor and Dunbartonshire Area Team Chair. And he enjoys opportunities to promote enterprise engineering and manufacturing within schools. Paul's talk is engineering skills for net zero and sustainability. So thank you, Paul, and over to you.
Thanks, Caroline. Can I just check everyone can see my screen? If you can just let me know that we're good to go.
Yes, Paul, I can see it.
Great stuff. Okay, thanks very much, everyone. So yeah, I thought it might be useful today to talk about the sort of broader picture of where companies are on the general journey towards net zero and where they are working. And I'm going to use the examples from our own program, net zero skills program that we've been working on since April. And I thought some live examples of where companies are and what we're finding, some surprising things, some things that we expected, and very much a moving picture. So the skills program was something that we put together at the end of last year. We were aware that there was a possibility that the actions for net zero and for climate emergency was something that could either be very much viewed as a carrot or a stick to SMEs. And the carrot being that there was real opportunity within it as things changed, as to make sure that their business was sustainable. And the stick being that if they didn't get on board, then they could get left behind either through procurement processes that asked for that action plan that they had, or other legislative measures that could potentially leave them behind. So we, in conjunction with Skills Development Scotland, we put together a programme for net zero skills and launched it, as I say, in April. The programme was primarily aimed at SMEs and really at whatever stage they were in their net zero planning. And I say primarily because we've been surprised the split of larger companies who we thought would be more independent and ahead in this respect has been not what we expected. We've probably been about 2/3 SME, 1/3 a larger company split. In the first 4 months, we had 104 companies engaged in both webinars and one-on-ones with us, and 32 organisations have come forward and asked to have one-on-one support with us at least once, sometimes 2 and 3 times. And we've had 248 attendees across the first 5 webinars. So what does that say? It says to me that there is a demand, there is a willingness out there. It's still probably scratching the surface a bit. It's the tip of the iceberg, but it has also felt through the programme that something that's been accelerating in terms of its interest as it picks up momentum and maybe a bit of word of mouth spreading. Our aim to get companies is to get them to think about their path to net zero very much using the kind of tools that are already to hand. So in our case, we encourage them to think about the 5 W's and the 1 or 2 H's, sort of standard lean tool that they're mostly all very aware with. And that first one is getting them to understand why are they doing this? Why are they in this? Why, we can understand that consumers care, certainly their customers will, employees, their competitors are an important part of that. Where SMEs sit in the tiers, and that's comes very much to that procurement piece. And then whatever else is coming in terms of conditionality and taxonomy, and other policy levers which may land on their door. So early on in the programme, I suppose we were a little surprised at the initial conversations. The initial conversations with companies where companies clearly thought quite a lot about this situation, and they really did come to us with a view that was quite clearly advanced and what they were interested in. That interest was in innovation. So I think it was in the second webinar we asked, what's the priority for the next years? What do you want to hear from the next year of webinars? And exactly matching the conversations, the majority of people were coming back saying, what we want to see is we want examples. We want to see what good looks like. We want to see what examples of innovation are both in Scotland, across the UK and around the world, so that we can take those and understand how we can leverage the skills and opportunities from that. I'm going to come back to that because that's something that's changed over the course of the programme, but that's certainly initially where we were. And then we took the Scottish Government's update to the climate change plan, 8 chapters, and broke that down and said, what is it you're most interested in? And out in front by nose, waste and the circular economy, understanding that and how understand it could apply to their business. Second, electricity. Again, mostly companies who totted up the sums and said, that's probably our biggest carbon impact, and therefore we do something about that. And then lastly, or third place, the negative emissions technology. And we understand that one a little bit better now, and we genuinely believe that that is a desire for companies to get all their eggs out of one basket and spread them around a little bit. So a bit of diversification. and principally in that case, reusing the skills, knowledge and experience from oil and gas technologies that can be reapplied for negative emission technologies. And then the last one on signposting, if you wanted a direction on signposting, what would the most beneficial areas been? So these were the top 3 out of a number, and it was skills. It was how to get a roadmap, simple help to sit down and have a roadmap that gets them to a smart commitment, and how to publicize it and track its progress, and the opportunities. So again, back to that overlapping with the innovation piece, how do you take that and actually turn it into something that is going to make a sustainable element for your business. Some of the surprises again. So again, the next one, once you go past the why, is getting to the what. And I said before that we had, some real interest in chapters 1 and chapter 8, electricity and negative emission technologies. And the negative emission technology, again, I'm going to come back to later. The electricity one was interesting in so much as where we found ourselves with this company was just trying to get them to step back and look at the big picture. So we had a few conversations where companies would say, we've thought about this, we've looked at our energy demand and electricity, and what we think we want to do is put solar panels on our roof and put up a wind turbine in our yard. And that may be the right answer for them. It may be, something that fits in with their overall strategy, but as likely we were saying, until you've seen the whole picture, we'd ask you to pause on that, and look at, for instance, just changing your contract to make sure that you're procuring only energy sources from renewable sources. So, maybe a little bit like the sort of engineering kind of behaviors that I think we all know, and certainly I live every day, we sort of jump on and jump to conclusions. And so there's very much this idea of trying to get people back to a process of step back, look at the big picture, and make sure you're really looking at everything across the board before jumping in. I put this one up. You can read the parts yourself, and I'm no doubt most of you will have seen these before. In terms of, and I think the theme for this one is really about what you do in terms of how that ensures your future talent pipeline, and people who want to come into your business, and particularly young people. And in this respect, one of those levers goes back to the why. So met with a oil and gas company last week that said, in terms of recruiting young people, as an oil and gas sector based company, we may as well be in the tobacco industry. That's the perception that we're seen to have. And so that getting to the bottom of the whys of why is this important to us, and sustaining, skills and sustaining talent coming into the business, of course, is super important. And then landing on the how do we reuse the skills that we've got in high pressure gas systems for other technologies, which are very much part of the solutions to get to net zero. So I start sharp on that, and I think in terms of the why do companies care, just a real highlight as to for one group why that is so important. The when now, I think looking at that graph of how you get from where your carbon output is just now and understanding all the way down. This has been the bit with companies is, again, go back to that step back and look at the big picture. You have to be prepared to do all of the accounting first. And so there's a fair bit of this that talks to process. How are you going to do that? Are you going to use your ERP system? Are you going to use whatever accounting other method you've got, so that you get onto the situation where you have a column for pound, shilling and pence, and another column for carbon? But really holding back on that piece to understand your whole picture and what your actions might be. Again, some of the early conversations we had with companies were jumping to offsetting. How do we get to what we should do about offsetting, and really getting that idea across? Well, first of all, you need to look and see what you can do to reduce, before you can get to that point of adding everything up in terms of where your offsetting might be. So, again, going through the W's and trying to ground companies in terms of that, where they sit. The conditionality one is one that I think I'll come back to that point, which is we had heard from companies last year from our own SMEs who were saying that in procurement processes, they were starting to get the first heads up that we're going to be looking for what your route map to net zero is, what your action plan to net zero might be, and it'll be part of our procurement policies going forward. So unfortunately, simply a gate at which some of these companies may just fall out because they don't have the required plan in place to do that. And right behind that, another interesting one was questions about, and how are you going to accredit the method that you're doing that? So effectively standards. So which standards are you going to consider using? And then for us, companies coming forward and saying, well, I can see there's a UK-based standard, which is PAS standard, or the ISO standard, and try to help those companies understand where they sit both within their own ownership sphere. So if they're internationally owned, they may end up, that the international standard is one that they should look like. Whereas if, if they're independently owned and sitting in the UK and trading mostly in the UK, then the UK PAS standard may be the thing that most enables them and their customers to have confidence in what they're doing, from a net zero point of view. I said about innovation before, and really, our initial conversations were all about innovation at the heart. And we found this really useful to try and, get companies to understand that you really need to be understanding the whole part of the wheel. You need to be looking at social trends, technology trends, your own company strategy and market trends to hit that sweet spot. And there are a few areas within there where if you're not considering the whole picture, you can fall out and be doing things that really aren't moving your business forward. Another interesting set of conversations was around the learning model. So understanding and for companies who say, well, how do we get everybody on board for this? How do we make sure that everyone understands why it's so important? So just like, again, very much a step in lean processes within a company, people don't understand why they're doing is important to both the company and to them for the sustainability of the company and therefore the sustainability of their employment and the success of the company, then those programs can struggle. And it's exactly the same with this. But going beyond that to understanding, the education model or the skills development model, which most of us grow up with at a certain age, has really changed from that 1980s model to the OSF model. And we had a few conversations, and maybe even myself included, where they looked at that 40-30-30 split for executive and thought, wow, that's a definite change and something that we need to think seriously about in terms of splitting up our resource to hit that ratio. So that was very much a conversation that was, a surprise for some companies as we go through. And then another useful one that we found that developed over those first few conversations, this innovation one, which is you really need to be looking at this, in the steps, the why, the what, the how, and the when, or the vision and the motivation, the capability, and the roadmap. And the graphic you can see for yourself. If you've no vision to start with, then you are going to be providing nothing but confusion both to yourself and your employees. If you have the vision, but you're not explaining to employees, you're not bringing them with you, if you're not explaining to your customer why that's important, what you're doing, then you will not have the motivation and you'll have resistance to what you're doing. And the others you can read yourself. So, but laying this out has been, as we found, has been useful to companies who understand that need to take things in a stepwise and get a big picture view overall. I think the last one, this slide that I wanted to talk to today is, so we had taken this approach of trying to get companies to think about this in the 5 W's and 2 H's. And we also try to get them in this idea of splitting their processes up into the discover, the define, the develop, and the deliver phase. And again, I've said it too many times maybe now, is that you need to look at the big picture first. You need to do your full consideration before you go on and step through. We found companies that seem to be jumping ahead rather than take that stepwise approach. And then our kind of methodology of then bringing that back to these chapters that are within the Scottish Government's update to the climate change plan seems to be really useful, because some mean more to others than they do to the rest. And at that, I want to say that there's a big part of this, which is where we've seen so far, is that this why question is really important. Initially, the companies we were engaging with were all about, we've done our homework, we've done some stuff, we know where we are, we know what we want to do, we want to look what good looks like, we want to understand how we build the innovation in either to the way we operate or our goods and services to move us along this journey. That has entirely changed now as we've got more companies on board. We've got companies who are coming on because they've had that first shock of a procurement process that says, if you're not on board with this, then you're going to fall foul of our selection process. We've had companies who have come and said, we don't want to be associated with being the equivalent of the tobacco industry. We need young people. We need a future talent pipeline, and there's all the reasons that you can think of why this is important and why they want to go on board. And so we're seeing a much more across the board fractured position of why companies are coming to us, and they're at different stages, and some, interestingly, are really very much back at the start. I'm going to stop at that. I think that's my time. So I hope that was useful in terms of the realities of where Scotland's mostly SMEs are just now in terms of that, some of the surprises for us, and I suppose the important or maybe encouraging thing for me to take from that is we've had no problem getting companies interested in this. They have come to us, and right now, that feels like something that's only growing. And I'll stop at that. Thanks very much.
Thanks very much, Paul. That was very interesting indeed. And I loved the way you presented it in really simple terms. It's all about the 5 W's and the 2 H's, and having a nice sort of map of the strategy and making it simple in some ways for SMEs and other industrial partners to see the way forward and what it means to them. So that was great. So thank you. We're moving now on to our final speaker. But before we get into that, I'd really encourage you to get some questions down in the chat. It's a great opportunity for you to ask these experts and knowledgeable people any questions that you have. So our next speaker is Stuart McKinley. Stuart is the Skills Director of the Manufacturing Skills Academy in NMIS. And Stuart's a graduate of Strathclyde. He's got a Master's in Manufacturing Sciences and Engineering, and he opened a manufacturing plant in Aberdeen making helium speech unscramblers for deep sea divers, which is very interesting, and it culminated in the role of General Manager. Stuart later worked for the Sector Skills Council in Scotland, responsible for engineering modern apprenticeship frameworks, and in 2015 he joined the Engineering Academy at Strathclyde, where his role was to support employer talent pipelines and the widening access agenda. In 2020, Stuart took on his current post as the Director of the Manufacturing Skills Academy at NMIS, and he was previously the Chair of the Scottish Association for Engineering Education, and is currently a board member of both Equate Scotland and Skills Development Scotland's Engineering Skills and Leadership Group. Stuart's talk title is Manufacturing Skills, Sustainability and the Circular Economy. So over to you, Stuart.
Thank you, Caroline. Can you hear me and see my presentation okay?
Yes, all clear, Stuart, thanks.
Thank you. So thank you everyone for coming along today. As Paul said previously, it's a moving picture. And certainly the world of skills and training can be an exciting moving picture, particularly if you're not buckled in and you're not looking ahead to see which direction the vehicle is going in. Equally, we're all been in the position where, like the circular economy, we've come back full circle and maybe decided that we want to go on a different ride. I noted John had talked about the whole systems approach, and I think it's equally important when we talk about skills to recognise that for sustainability, we need to be talking about both the subjects concerned and the system in place to deliver those. And indeed, there have been some great examples of that previously, and probably the most relevant one at the moment is the development of the Engineering, Design and Manufacturing Graduate Apprenticeship Programme. Minimise that. And the general philosophy of that was actually that of a three-phase diagram from metallurgy, looking at a percentage of full-time work, full-time study, and work-based learning. And many of the graduates from institutions that are delivering these will come out this year. So I think that's been a major success for Scotland. But interesting, I think it's not inconceivable that in the near future, we might see some universities actually stop delivering full-time study in-house, and actually that's done through the work-based component entirely. Talk briefly about the challenges and opportunities, and it's no secret that Scotland's the best performing, certainly in terms of OECD and Eurostat numbers, in terms of percentage of the tertiary education that's percentage of the population rather that's have a tertiary level education, and that's in direct contrast to countries like Germany, where you might have anticipated would have been a bit higher. But actually then when you look at our productivity, it's absolutely below the average for the second quartile even, and a long way behind some of the others. And there's a whole bunch of different reasons and different ways of measuring productivity, of course. And there's a larger discussion to be held on productivity measurement, particularly as we look forward to some of the kind of conversation coming out in terms of engaging with people, engaging with millennials, and including things like the fair work and the just transition, to ensure that that productivity measure is actually a societal one. Interestingly as well, there are a number of cultural challenges, and I think these two stats always stick in my mind as ones that are particularly relevant when we talk about skills for the majority of engineering and manufacturing companies. And that's that most people actually get very little time in any given week to do formal training. The average was somewhere around about 10 to 11 minutes. And perhaps also significantly, the average UK worker ceases formal education around the age of 40. And I'd probably guess that most of us on the call today are over that mark. That has, of course, significant challenges in terms of missed opportunities, where often those who can contribute most to a business are those who've been in the business long and actually are most loyal and actually still want to deliver. There's a bit of a fallacy or a misnomer about their ability to take on board digital translation, digital education. They're obviously most experienced and often the ones that want to keep driving the business forward. There's some well-recognised issues around about technician level shortages, particularly across the UK. And then looking to the future, I think we see more of the same as in the changes that are coming. So LinkedIn saying that 74% of learning leaders looking to deliver more online learning in the future. And when we look at net zero and digital transformation and the changes that will require, at one end of the spectrum, we've probably got somebody like Red Bull, 10,000 engineering changes per month. What kind of system do you need? What kind of culture do you need? What are the skills needed to be able to handle that level of change? And when we look at, the net zero part about the green jobs, we realise that actually some of these jobs, we don't even know what they are yet. So how do we remain agile enough in a situation where you don't quite know what the road ahead is? And then there's a discussion around about what are green jobs and what are greener jobs. And there's a good paper there from Nick Sofroniou and Pauline Anderson. We are well recognised in Scotland and the UK as being good at innovation and good at R&D. And as Chris alluded to and covered off earlier on, that's part of the role that NMIS has to play, is that translational part. So actually helping us improve that productivity through some of the bedrock that we actually already have here. And finally, on this slide, probably just a couple of notes of caution in terms of online learning. Yes, we've all seen a huge increase in it, but actually some of the early data coming back from the States suggests that the areas such as technical subjects are most affected by online learning in terms of a lowering of performance, and also particularly for the kind of just transition bit, those who are suffering from social deprivation are the ones that suffer most from online learning. And probably the biggest subject where this is seen to impact on is maths, which clearly underpins a lot of engineering and manufacturing. The other data coming through, and it's largely anecdotal at this stage, is, you know, certainly in Scotland, we've had a number of years now where school kids know that they're probably not going to be any tests at the end of the year, or there's less likelihood, and that is starting to impact on some of the behaviours that teachers are seeing through the year. And of course, at some point, those kids will leave school and they'll go into college and into university and into jobs, and we will begin to see that hitting the system further down the road. But there is evidence of change and development. A couple of people on the conference today have talked about the Climate Emergency Skills Action Plan. If you've not read it, go and do so. It's highly recommended. I would also encourage you to go and look at the Scottish Scientific Advisory Committee report on the environmental impacts of the Scottish manufacturing industry, which was led by SRPe, who we work very closely with. And there's also the OECD review of the apprenticeship system in Scotland, which had a number of recommendations, and certainly from where we're sitting within the Manufacturing Skills Academy and the employers that we're talking to, probably the one of most interest was their fourth recommendation, to establish a Master Craftsperson qualification. Now, we are actually talking with SDS just now about the development of a graduate apprenticeship, kind of notionally titled Digital Manufacturing to Net Zero, but at a master's level to sit above the current qualification, current framework, but also to explore a feasibility study on a doctoral apprenticeship. So what would that entail? What would that look like? And would that raise or cover off some of the issues raised by OECD and others? And we've certainly had demand signals from employers, you know, from Leonardo through to Shell, of our interest in that whole area. Significantly, I think BAEs now are beginning to shift their position. A report in the last month or two about R&D, people and culture strategy, and that actually mentioned skills 41 times during the report, and that is unprecedented that a BAEs R&D report would, you know, use that particular word. So clearly it is coming to the forefront. Additionally, the Catapult have a new strategic plan. We're actually looking to work closer together. And I know Chris again showed you the map earlier on, outlining where the locations were, but we're actually looking to see how we can work closer together across the UK. And it's been recognised now that skills and workforce development are one of the three legs of that three-legged stool, along with the R&D capability, the translational R&D capability, and the supply chain in terms of employers and stakeholders. And on top of all that, we've got all the good work from the likes of Scottish Engineering and SDS. So our current activity, you know, what are we doing about it? Current activity, we have a doctoral programs, both with the Catapult and with SRPe. We have an Advancing Manufacturing Challenge Fund programme. You can see the title there, and that's free of charge content to SMEs across Scotland. And I should say that other AMCF programmes are available across Scotland, including at least one other that NMIS has direct responsibility for, and others that we are involved with. And currently we're spending a lot of time and energy with the National Transition Training Fund. We were asked by Scottish Government to support the Manufacturing Recovery Plan and the impacts of COVID and Brexit. And probably two of the biggest impact areas for the audience around the table are the space and about CPD content and the programme we did with graduates. I'll expand on those a little bit in a second. But we're also working within NMIS. You saw the strategic priorities that Chris had put up earlier on, the strategic innovation priorities. We're working with the Catapult, we're working with partners, and we're working with employers to identify future needs in the net zero and low carbon and digital translation arenas to ensure that we are putting adequate and proper training provision in place at the right time. Just give you a kind of quick fly through some of the content that we've developed working with external partners. We're always interested in working with external partners. NMIS cannot, and certainly the MSA cannot and will never deliver everything. We need to work with people who are experts in each area. And so we've utilised some internal provision and working with external partners, universities and colleges across the length and breadth of the UK. And down the road, I would see that increasing on an international and global basis. Maybe just to give you an example, often in skills, there's lots of talks and there's nice glossy reports about some of the skills challenges, and green jobs and the net zero agenda is no different. But actually, as soon as you go underneath the first layer, there's almost nothing underneath that, and that's the bit that everybody finds really challenging. So what we are doing is stepping into that space. An example, if you work with technology, Scotland and Photonics Scotland, it's over £1 billion a year industry for Scotland. And the vast majority are SMEs, big majority of the experienced skill shortages. And when you do the survey, then there's all the kind of usual things come out of that. But actually, by sitting down with the players, both the large employers and the small employers, we were able to identify a course, a 2-week programme that actually takes away a lot of their pain. And we worked with external providers to identify that. The employers have identified what their demand is going forward, so we know it's sustainable. And it's been funded under NTTF, so we can actually put people who are suffering from unemployment or being at risk, put them through the course. A number of the employers have given guaranteed interviews, or will give guaranteed interviews to those that pass the test at the end. So in terms of that sustainability aspect, it's looking at what are employers' needs, what are individuals' needs, what are the country's needs, and trying to make sure that all of that lines up and looks not just in the short term, but actually is building sustainable content going forward. The graduate programme I mentioned, we've tried to do something similar. So we had funding to recruit 30 graduates who'd been unable to find work due to COVID and the pandemic. And we've embedded them with employers across the length and breadth of Scotland, from Pipeline Sentry in Aberdeen, Port of Cromarty Firth, looking at the Scotland leases and the Green Ports bid, down through Power Photonics in Dalgety Bay and Mask Logic in Edinburgh, who make masks for NHS and others. And in fact, some of these graduates are actually working within NMIS on the remake test beds, both the carbon capturing and the validation for the remake and remanufacture that, again, Chris mentioned. And we have another graduate working in the lightweight manufacturing centre as well. So with little kind of effort, really, we identified a lot of employers who are interested in taking on a graduate in addition to whatever else they were doing. And some, so the likes of Renewable Parts, were actually happy to co-invest. So they've taken the graduate, we're paying them a real living wage, but they're actually topping those up to allow the graduate to be able to live in Loch Alped. And Alvance were another company that did the same.
Stuart, sorry to interrupt, but I'm not sure how far off you are at the end, but we'll need to stop soon. Thanks.
Okay, I've got a minute to go. I calculated. So just very quickly then on what looking forward, NTTF2, 5 programmes coming up there. The key ones to the audience around here will be developing CPD material on the net zero carbon and sustainability proposition. If anyone's interested, happy to have a chat with you. Creation and launch of a micro-credentials programme that provides some of that agility I talked about earlier on, and the continuation expansion of the successful first graduate first job programme, and that will include both university and college graduates for the next phase. So I will stop at that, and thank you and look forward to the Q&A session.
Oh, okay, thank you very much, Stuart. That was a really great presentation as ever, and I had some comments myself, but in the spirit of time, I think we'll move on to the Q&A part of the webinar. So I've got some questions lined up and a few are flowing in as I speak, and we'll try and cover as many as possible. But what I'd like to say to all people concerned and involved in today's webinar is if your question doesn't get raised in the time left, feel free to get in touch, and we'll try and direct questions to the presenters. I'm sure they won't mind that at all. So to kick off the Q&A part, I've got one for the whole panel, and it's around what do you see as the key barriers and challenges for companies to adopt sustainable manufacturing practices, and how do we de-risk the pivot into a sustainable environment, in particular for SMEs? So I'll open the floor up to presenters if anyone would like to jump in with a first response. I can't actually see the presenters, so maybe if you could switch your screens on, that would help as well.
So I'm happy to go first, Caroline, if that's okay. So I'll put my MNIS hat on. So what work we've found is it's very difficult for SMEs to actually understand where to start, and the net zero journey is different for different companies from different sectors, manufacturing sectors. If they're a manufacturer of components, they're interested in how to decarbonize the current operation. There might be high energy intensive processes, or they might not understand the business models. It's what we're trying to achieve here is a network of knowledge exchange and communications where we can bring SMEs to companies who have previously undertaken a journey to understand the key steps that they need to assess themselves on, but also to strike up the conversations where they can discuss their options in a non-competitive environment, because net zero isn't necessarily where USP is concerned. It's a target that all industry need to achieve, and they need to start. And it is a journey. There are different solutions for different companies by the nature of what they provide as a service or product.
Thank you, Paul. Does anyone else have a comment on that question, a brief one, and then we'll move to the next one?
Caroline, I'd like to add one, if that's okay.
Yeah, go for it, Paul. Yeah.
What Paul's just said is absolutely right, and I think just to add on to it is that sense that when you look at net zero and a net zero action plan, it just seems so huge, and particularly, we've met companies who they've jumped ahead of scope 1, scope 2, scope 3, and just went. And the principal challenge for SMEs is resource. They don't have it. So either something comes along which provides a lever, like the procurement example, or something else. And so I think the biggest thing is to try and get them to understand that you can put a relatively small amount of resource at it and tick it over and get it moving. And once it gets moving, it like any other program, it sustains and goes forward. It doesn't all have to be done in 6 months' time or 6 weeks' time. There's a very long-term, marathon, not a sprint. I think getting that across, I think, is our big challenge to try and get people on board.
Yeah, that's great, Paul. Thank you. A very pertinent response. I've got quite a few questions to cover, so I'm conscious of time. I think I'll move on to the next question, and it's really again for all presenters. What are the key priority areas for Scotland in terms of sustainable manufacturing innovation, and is there policy in place to support this? So it's more, I guess, about priorities and policy requirements. If anyone would like to take that up. I've got resounding silence. Paul Cantwell, you look like you're about to say something.
Yeah. So, policy, there needs to be policy and incentives to help drive. I believe we're beginning to see this come through with public contracts, dictating that companies need to demonstrate that they've got a net zero strategy. I think, again, there's different solutions for different industries. We need to look at how we're going to support, say, energy intensive industries to decarbonise. Scotland is predominantly SME based for manufacturing, and they've got a lot of potentially aged infrastructure. So we need to help them to develop technologies to retrofit, because there's not necessarily going to be the funds to enable them to procure new. And it's more to support them on that journey to identify, I think, kind of pilot demonstrators. So it's sharing of best practice, sharing of knowledge to speed up the adoption of the practice. And we were leading on remanufacturing service servitization models as Scotland. We've got great strengths with Zero Waste Scotland existing, so there's true value to be kind of had there to pull on existing knowledge into new industry sectors. And if companies are interested in topics, let us know and we can organise those events with existing small to medium-sized enterprises who already act commercially in these sectors, in these environments, using a sustainable business model. So Caroline,
yeah, I'm back. That's great. I was saying thanks for that offer, and I'm sure people will take you up on it. Would any other presenters like to add a comment on the back of Paul's? Nope, I'm not hearing anyone, so we'll move to the next question. Thanks. This is a question directly for Paul Sheeran. What is the practice Scottish Engineering recommends for companies to adopt to calculate their own carbon footprint?
Oh, okay, thanks for that question. So we've kind of got a template that we're working with companies for. We're encouraging them, in some cases where it's coming in to them to look to their suppliers, because their suppliers may already have that information. I'm struggling to answer it in a useful way to everyone on the call. I'm going to stick my email in chat. If that's something you'd like to follow up on, I'd be really glad to do that. But I think I could bluster my way around this one and make a really bad job of it, but I'll do that instead.
Oh, thanks, Paul. I appreciate it's a difficult one to answer in a very short space of time. It's quite a complex challenge. So we'll move to the next one. Regarding manufacturing made smarter, is there scope for industry and academia to drive more circular economy sustainability business model elements in new applications to innovate under their MMS programme? Yeah, manufacturing made smarter programme. So scope for industry and academia to drive more circular sustainability business model elements in new applications to innovate under the programme. Any thoughts?
Yeah, sure, I'll jump on this one again. Oh, sorry, Chris, go on.
No, Paul, go on.
Yeah, sure, thanks. So yes, there is kind of Innovate UK are just now kind of developing their net zero strategy and themes. So they are going to heavily focus on how to enable and incentivize more sustainable practices to be adopted within manufacturing, from both business model, certification, qualification, and decarbonisation of existing infrastructure. And it's a good point that in the future there will be a heavy focus on what the net zero aspect of applications are and how you could demonstrate the actual offset of potential embedded carbon or greenhouse gas emissions in any technologies to be developed.
Okay, that's great, Paul. Thanks. And Chris Dungy, would you like to add to that?
Yeah, just adding to Paul's comments really, and just picking up the theme of today's session. That I know him pretty well, but it's an absolute vital consideration to enable this to be adopted by industry, because they need to make this work from a cost. It's got to be cost effective, so the economics have got to be right as well. And I think Ian put on one of his slides, I really like that, and hopefully we might be able to borrow it from him. But the complementary nature of this, that if you're applying servitization, it leads to this net zero opportunity, but also is cost effective for your business. So I think that there's something that needs to be developed further there. And I'd strongly encourage us lobbying in the Made Smarter Commission to say that we need to focus on not just the tech, but clearly the business models here, and the through life engineering services aspect. I think that's fundamental to making this stick, as it were, in terms of an approach towards sustainability.
Yeah, Chris, that's a great point. Anyone want to come back on that quickly? Nope.
Can I just add something as well?
Go for it, Paul.
It's great to talk about Innovate UK made smarter. There's also an opportunity for us to look close to home as well with the green jobs growth, the energy transition fund, and the low carbon manufacturing challenge fund, all just around the corner from launching. All a prime opportunity for us to develop regional pilots and demonstrators for industry who have the appetite.
Yep, excellent point, Paul, thanks. So I'll move on to the next question. This is for John. In in terms of adoption of TES and digital technologies, where are we today in Scotland and the UK compared to where we actually need to be, and what key interventions are missing?
I think, yeah, thank you for the question. I mean, I think at a national level, it's kind of hard to provide any stats, but if we compare the UK to other countries, that there's a number of reports which shows that in terms of manufacturing productivity, we're behind, and that's largely attributable to the level of adoption of digital technologies. So, and I think at this point, it's also worth highlighting the skills kind of variation between UK and other countries. And I think, you know, the mastership, apprenticeship type schemes are really important along these lines. But overall, I think there's a number of things we need to think about. And I think, you know, we need to look at both the skills and the digital technologies and organizational culture, maturity, all those different elements together. And I think the other aspect to really think about is the ability to integrate technologies. And this is particularly a challenge that we're facing, in that there aren't potentially the sufficient number of technology providers within the UK to cover all the different elements that we need. So there's still a heavy dependency on importing technologies. And I think that's also creating a number of barriers. So are we there? No, I don't think we're there. I think there's a lot more to be done. But I think the recent research funding that's being made available is really going to help. And I think the more recent kind of focus to develop digital related courses, training opportunities is also going to help. I do think we need to think about how across the supply chain this is going to kind of flow through, rather than particular organizations taking up these opportunities, so that we do fully benefit from all these opportunities.
Okay, thank you very much, John. That was a very thorough answer. We're running very short in time, and there are a number of questions that I've collected which we won't be able to go through. So I apologise for the lack of time to respond to those live, but I will pick up on those and direct them to the relevant presenters and try and follow up. So we're now at the stage where I'd like to say again my sincere thanks to all presenters for your excellent presentations, and also thanks to everyone who's attended today. And I'm sure you found it as interesting and insightful as I have. So do feel free to submit any further questions to us, and we'll try and direct them to the right person. So I'd like to mention that this is one of a series of webinars under the Energy Innovation Emporium 2021, being led by ETP. And there will be 4 more of these webinars in the series to come. And you can sign up to attend these via the ETP website. They are on data-driven innovation to net zero, the importance of science for marine renewables, bioenergy for future energy scenarios and beyond. And there's going to be a closing ceremony led by the Scottish Government and Scottish Funding Council. So as I mentioned, all of this you can see on the ETP website. So again, thanks again to everyone, presenters, attendees, and for all the questions, and we hope to see you at the next webinar. So have a good day. Thanks everyone, and bye.
Thanks all. Bye.
Thank you.